Hello children, welcome to channel Sube. Today I am going to discuss MCQ question number 34 of 2019 Physics New Syllabus paper. A test tube is made to float upright in a fluid by placing a metal ball at the bottom of the tube as shown in the figure. Total mass of the tube and the ball is simple m. So the mass is given. Let's write it here. Total, we don't have to take separately. Density of the liquid is rho, it is given rho, and the cross-sectional area of the tube is capital A. Cross-sectional area, this area is capital A. Effect of surface tension and the viscosity of the fluid can be neglected. If the tube is given a small vertical displacement, that means they push this down into the water. Displacement, what is the period of oscillations? Capital T. They want us to find period. Period means capital T of oscillation of the subsequent motion of the tube, because after pushing this down and taking our hand away, what happens? This tube will oscillate like this for a few seconds. First of all, let's draw the diagram to show the second incident. So this is how we can see the test tube after pushing it down and before we take our hand out. So at the instant when we take our hand away from this test tube, this is how we see it. So as soon as we took our hand out from this away from this test tube, at this instant we have to consider the forces. Actually, before that, for convenience, let's first consider the forces acting on this first test tube. So definitely the weight is there. So I draw it like this. Usually we draw mg, because they have given the mass as m, the total mass. So the force downwards is mg. So they say the test tube is floating. A test tube is made to float upright in a fluid by placing a metal ball. So that means the test tube is floating. So if it is floating, that means it doesn't move up or down, and it doesn't rotate clockwise or anti-clockwise. So that state we call equilibrium state. In equilibrium state, the forces opposite to each other are equal in magnitude. So what is the opposite force to this mg? That is, upthrust given by this liquid. So we can represent it by an arrow, that is a vector. So since it is equal to mg in magnitude, I take the same length. That is how we have to draw or represent actually these vectors. Just we draw like this and without considering the magnitude, the length of the arrow, that is wrong. So therefore I draw the arrow whose length is equal to this length of this mg. So the upthrust is U1. So assume the upthrust is U1. So it is given by this fluid because there is a pressure. So by that pressure there are forces perpendicular to this test tube. So the resultant is the upthrust. When I was talking about pressure, I marked arrows here like that, like this. But don't get misunderstand that pressure is not a vector. I said pressure here like this. I marked a point for pressure, and I said the force given by the pressure is like this, perpendicular to the test tube. So these arrows are not pressure, these arrows are not for pressure, these arrows are for forces. These arrows are for forces. So it must be get clear, otherwise you will misunderstand. Don't misunderstand. These arrows I marked to represent forces. Pressure is a scalar, it is not a vector, because we use an air pump to inflate a tire of a bicycle, but we don't at that moment consider the directions. So it is a scalar, it is not a vector. So children, now we can write our first equation. Since these two forces are at equilibrium, because there's no it's a floating, there's no rotation or motion up or down or left or right, so they say it is floating. That means it is stationary without moving, so it is at equilibrium. Therefore we can write mg equals u1. This is the first equation. Anybody can write here, because I marked, I created this arrow whose length is equal to the length of this force, which is representing the mg, the weight. So these two are equal. Therefore we can write mg equals u1. So children, now we have to consider the center of gravity. If I marked the center of gravity at this center point of this tube, is it correct? No, it is not correct, because this half of this tube is the mass of the weight of this half of this tube is greater than the weight of this half of this half, because there is a metal ball. Therefore this half, the weight of this half is greater than weight of this half. So therefore the center of gravity moves closer to this metal ball, because that end is heavier. Therefore if we mark it here, something close to this ball, away from this center point, so it is correct. So now I take the level of this center of gravity like this to the second figure, and then I take this length like this. No, I have to use another object like this. So I take this length, the distance from this center of ball like this, and I mark it at the correct place, even though this is just a sketch diagram, but I draw it more accurately as much as possible. So this level, using that measurement, that as a ruler, that box as a ruler, that frame as a ruler, I I mark the center of gravity exactly at the exact point, at the exact place. So the level is this. After pushing the tube down, the center of the level of the center of gravity, the location is this level, at this level. So what is this length? That is what we call the displacement of the center of gravity. So we write it by S, the letter S, because S is the letter to denote displacement, because we write velocity equals delta S divided by delta T. So this S is the symbol for displacement. So that is the displacement of center of gravity. So we have to consider that point, the center of gravity. So it is like that. So now, so children, I made a mistake here. Did you notice it? Because now we know the center of gravity, the points are located at these places. So then only we can mark this force, because that is the place where this force act on. So this, all these forces are wrong. I have to redraw them. Sorry. So at least I found it after all. So this mg must be acting on this point like this, because earlier I had not marked these points, the center of gravity. So this must be equals to this length equals, the lengths are equal. So this one is u1. So equation already we have written. Now let's correct this one also. Blue color. This length we have to take, because mg doesn't change, it is constant. So acting on this center of gravity, that is the point of, that's the point on which the force is acting. So how to mark this upthrust? Should I take the same length? No, it is wrong if I mark like this, because now the length in water is greater than the previous one. This L1, this L2. L2 is greater than L1. Therefore, the volume that displays, the volume of water that displays at second time is greater. Therefore, the upthrust also must be greater. You know the equation for upthrust. Do you know? The equation for upthrust is V rho g. What is V here? The volume of water that is being displaced by this object. So imagine that all these objects are in a beaker or a vessel like this. Just the rim, the brim of the beaker or the vessel is the level is equal to this water level, at the same level. So before we put this test tube into the water, so after pushing it to the water, what happens? The water spills out, and we can collect them to a tray, and exactly the volume is equal to the volume that is under water level, this one, this level, this volume, these volumes are equal. So we call this amount of water the displacement in Archimedes' principle. But certainly remember that displacement is different from the displacement we talk in mechanics, the vector displacement, that is. So this displacement is the excess water that flows out from the vessel. So don't get confused these two displacements. What is Archimedes' principle? Archimedes' principle, you know, is like this. The upward buoyant force that is exerted on a body immersed in a stationary and uncompressible fluid, whether fully or partially, is equal to the weight of the fluid that the body displaces. So this displacement is different, even though the words are alike. This displacement, that is different. If the tube is given a small vertical displacement, the vertical displacement is this. In mechanics, the displacement is this. Not only that, the word they used this displacement also wrong here. We should write the change of displacement, because the displacement in mechanics, the S, the symbol S, is measured from a fixed point. Imagine that there is a fixed point here, say the ceiling. As a fixed point, we can use the ceiling of the building. So say this one is the fixed plane. So from that, the distance to this point is the displacement 1, S1. Displacement is what is the displacement? The definition is to a point, to an object, the distance from the direct distance, the straight distance from a stationary point. So the stationary point we can't change it. So this to this point now, the displacement must be, we say, the second time displacement, S2, is this. So this one is the change of displacement from here to here, change of displacement. That is why we write V equals delta S divided by delta T, the change of displacement in time delta T. So we get confused when they used words like this in a wrong manner. The displacement is, this is the motion, this length is the length that this center of gravity moved from here to here, it moved from here to here. So that is not the displacement, that is the change of displacement. Displacement must be measured from a fixed point like this. So however, we don't criticize those things. So however, this is the Archimedes principle in words. So we must write stationary. Stationary. The fluid must be stationary and uncompressible. That means we can't change the volume by applying a force. So those two words are essential. So the weight of the fluid. First of all, we have to get the volume and multiplying it by rho g, then we get the weight of the fluid. What fluid? The fluid that the body displaced. The body is this one. The body is this one. Under the body under water. This one is the body. So we can take it here like this, and the second time, so just the volume we take. You don't have to take this ball and the glass, this glass also you have to forget. And if we filled this test tube with water, so there is a weight. The weight of it is equal to upthrust here. So this weight can be calculated by V rho g. So that is why we write this equation, U2 equals V rho g. So V2 must be here now, because this volume is V2. This volume is V2. Here this volume is V2. So at the second time the upthrust is now V2 rho g. For the first time, what is the upthrust? The volume under water, we have to take Control C. Here first time, this is the volume that cause upthrust. Without this ball, only the volume we get is the margin. We don't have to consider the glass even. Here also same. I take time because this is not the exam. I like if you understand, that is why, because then you are happy. So do I. Because you are watching this video because you didn't understand, that is why. After this video I think you will be happy. So this one is the volume V1, the displaced volume after immersing this test tube into water. Some amount of water is displaced. That amount of water is this much. So the weight of that water is equal to V1 rho g. Rho is the density of this water, liquid. So that is why, so Archimedes said what? That weight is equal to upthrust. So that is why we equate it to upthrust. So the upthrust at the first time, U1 is smaller than U2, the upthrust at second time, because this length happened to be larger than this length at first time. Because how we calculate the volume? This volume we have to calculate. We have to calculate this volume. The cross-sectional area times this length, L1. So V1 equals, whenever we need it, we have to do it. V1 equals cross-sectional area A times L1. So here this V, it must be V2. V2 is equal to cross-sectional area times L2. So here L2 has been increased because we pushed down the test tube. So therefore volume increased, therefore upthrust increased. Therefore we can't mark the upthrust at the second time equal to the upthrust at first time. This one must be increased like this. I pull it like this, the arrow like this. So it must be larger. It must be larger. So now this diagram is correct, because this condition, under this condition we have to mark it. We have to understand that L2 is greater, therefore the upthrust must be greater. So here the upthrust U2 is given by this equation. So children, now we know this U2 is greater than U1. So therefore we can write here, I said mg equals U2, we can write here, because here mg is smaller than U2, because in this diagram you can see I explained all the way that U2 is longer, greater than mg. That means here there is a resultant force or an excess force. What is the resultant? Resultant force, the smaller one should be subtracted from the bigger one. The bigger one is U2. So U2 minus smaller one is mg. U2 minus mg. We subtract to get the resultant. So this one is the resultant force. Sometimes we write two lines here to Fm. So this one is the resultant. Now we are going to use F equals ma. Here when we use F equals ma, what is this force? That must be resultant. You remember that, otherwise you will get wrong answers. Resultant. Therefore we have to use this combination for that. So before we substituting, we can simplify furthermore, because we know mg equals u1. So instead of this u1, yes, we have to substitute mg, instead of mg, u1 here, like this. So F equals u2 minus u1. So we can substitute it here. F equals u2 minus u1 equals ma. So now what they ask is the period. So we have to go to simple harmonic motion now. So let's go to that simple harmonic motion. What is the equation? The basic equation: a acceleration equals minus omega squared s. S is the displacement. Which displacement? This one. This displacement we have to use here. So instead of a, we can find a from this equation: u2 minus u1 divided by m. So we substitute it here: u2 minus u1 divided by m. We don't have to write this minus sign. Why this minus sign is there? Because the direction of displacement is always opposite to the displacement, the direction of this acceleration. So if this way, or if this way to left, this one to right, always like that. Therefore this minus sign is there. So therefore we don't have to use that one, because we don't know, we don't use the directions. Just we write omega squared s. Now we are going to substitute for this u2 minus u1 for u2 and u1 from this equation and from this equation. So we write u2 instead of u2 v2 rho g divided by minus, instead of u1 v1 rho g divided by whole thing m m equals omega squared s. So rho g common we can take out of the bracket, v2 minus v1 divided by m equals omega squared s. So now we can write, instead of v2 and v1, earlier we calculated v2 here and v1 here, a times L1, a times L1. Then rho g a times L2 minus a times L1 divided by m omega squared s. So we can take a common out of the bracket, L2 minus L1 divided by m. Equals omega squared s. So what is L2 minus L1? Now let's go to the diagram figure. So L2 is the length under water level at the second time, L1 is this first time. So this one is L1 to this level, this length distance is L2. So what is L2 minus L1? L2 minus L1 is this distance. So it is equal to S. Why? All the points of this test tube, including the center of gravity, moves down together. So this point moved down to this level some length, and all other points of this test tube, including the center of gravity, must move down the same length, otherwise this test tube will break. So this L2 minus L1 is S. We can mark S here too. Then we have to write L2 minus L1. Instead of L2 minus L1, we can write A rho g. We write rho ga instead of rho ga, because in answers they have written A rho g. That's why the same thing. So instead of this thing, we write S divided by m equals omega squared s. So s cancel. Now we have to use another equation again, divided by m equals omega squared. Now we have to somehow get a relationship with this capital T. So what is the relationship between omega and capital T? You know omega equals theta divided by t time. When theta is 2 phi, then time is capital T, because in circular motion, you know, if the angle is theta, then the time to travel from this place to this place is t. Then this is the equation for this, theta divided by t. Here if we consider the full circle, the theta is whole thing 360 degrees, that means 2 phi in radians theta. Then the time to travel all this length along this circle, what is the time? T is considered as capital T, that is the period. So when theta equals 2 phi, the time equals capital T. Therefore we can substitute instead of theta 2 phi, instead of t capital T. So this equation you might remember, you don't have to derive it like this. So we write it here now, A rho g divided by m equals 2 phi divided by t, the square value of whole thing. Then we have to remove the square value, so we take the root of both sides, and then this one change into like this and equals 2 phi just divided by t without this square value. Then what they want us to find is t. So t, so we take this way, t, this goes this way, equals 2 phi root m, and this part goes down to the denominator, then a rho g. So m divided by a rho g, root 2 phi. The answer is 2 phi m divided by a rho g, this one. So second one is the answer for this question. Children, I think you understand, you can understand. I explained everything, even circular motion, simple harmonic motion, Archimedes principle, everything. This is a lesson. This is a lesson, not a problem work through. This is a lesson actually. So if you are happy, please subscribe my channel, and thank you for watching my videos. So do it again and again. Start your studying, don't wait until result come, because then you will not have enough time. Therefore start your studying, work hard. So thank you very much, see you tomorrow, goodbye.